All right, here we have some notes on solving systems of equations. It's actually a review, so hopefully this is something you're familiar with and have seen before. And to remind you what a system of equations looks like, a system means that we have multiple equations, not just one. And in order to solve a system, we're looking for any solution that is true for both or all of these equations. And here's what I mean. In this first equation, I could find a solution to this equation if I use a 0 for x. Let's see, this would give me a 3 for a y. So the coordinate 0, 3 is a solution to the first equation. But that is not a solution to my bottom equation. If I plugged in 0 here, this y would be 9. So this 0, 3 is not a solution to this system of equations. To solve a system, I want to find an ordered pair that makes both equations true, or a common solution between both equations. So a solution to a system of equations is a common solution in xy to both equations. There are a few different scenarios you could have. In scenario 1, or let's say case 1, you could have one solution. You can have another case where you have no solutions. There are no ordered pairs that are true for both of these equations. Or case 3 would be infinite solutions. That would mean that every single ordered pair is on both of these lines all the time. And if you're not familiar with what that looks like, we can look more into that later. So let's solve this system of equations. There's three main methods that you've seen to solve the system of equations. The first one we want to talk about is graphing. In order to solve by graphing, we need to graph both of our equations. So let's graph the first equation in green. So this is y equals mx plus b. Here is my y-intercept of 3, 1, 2, 3. And I'm going to use my m, my slope, to graph other points here. So up 1 over 2, up 1 over 2. And I can go the other direction, this way here. So let's see, I'm going to draw myself a line. Let's make this line green. And it's going to look something like this. Okay. There's my green line. Let's do my second equation in blue. So I got y equals negative 4x plus 9. So I need a y-intercept of 9. 1, 2, 3, 4, 5, 6, 7. Looks like it doesn't quite fit here. That's going to be 8. That's going to be 9 if I were to continue this line. And my slope will be down 4 over 1. 1, 2, 3, 4. Over 1, 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1. Let's draw that line that connects all those dots. And it looks something like this. Okay, and we can see there's an intersection that's going on here. This intersection is the solution to both of these equations. So this intersection, this coordinate pair, is looking like 1, 5. That means that 1, 5 is a solution to my first equation, where x is 1 and y is 5, and my second equation, where x is 1 and y is 5. I have solved this system of equations. That's graphing. So let's talk next about solving using substitution. We'll do that in the next video.